Welcome, everyone. It's great to see so many of you here. I would like to know who of you uses Elixir on a regular basis? Okay, that's almost everyone. And who of you uses Ecto on a regular basis? Okay, that's really most of you. So maybe I can make the intro a bit shorter. So I'm Arno, as Isa already mentioned. I have been developing this wonderful library for now 3.5 years across many steps of evolution. And the main problem is that database queries are slow. You have this famous n+1 queries problem if you don't watch out for it. So database queries are much, much slower as compared to running functions, like say compared to having the data in memory, in variables, and so on. And that's, of course, obvious if you look at it at a bit deeper level, because you have to not only build the query, you have to check out a connection from the pool of database connections, so that already involves a separate process. You have to send the query to the database through the network, which can cause latency and might take several hops. Then the database needs to parse the query. Of course, that can be cached sometimes, but that's one step that needs to happen. The database needs to execute the query, which actually is oversimplified because it makes one or multiple query plans according to statistics and more, and then chooses one of them, runs the individual steps in order to come up with the data. Then it needs to send back the results to your app, and the app needs to parse the results from the wire format of the database, and then also Ecto needs to generate result data structures. So for example, if you use Ecto schemas, then it needs to put all the results into struct. Maybe if you use Ecto preload, for example, it needs to nest them within other structs and so on. And that's all with immutable data structure, so a tiny bit slower than with other programming languages. But we have some existing approaches how to. So the problem is they are slow, so we avoid having too many of them. And we have some existing approaches, especially with Ecto, that I think everyone learns when they start programming Elixir or using Ecto. So one is handcrafted queries. You can basically write the database queries yourself. And with Ecto, you have some pretty nice DSL to do that with Ecto query. You can combine different parts of the Ecto query. You can make parts of it dynamic with a dynamic macro. And Ecto will then make SQL out of it. It has some validation as well. And then if it's valid and you combine it, it generates SQL and you can use that. But this is not that easy to reuse, because you have to cater it towards the use case that you're making the query for. So for example, if you have some dynamic parts, let's say just dynamic in the sense of some filters are in there or are not in there, then let's say those filters are related to some associations, then you need to join in the association. And if maybe you need that in several of the filters, then each of the filters needs to check, okay, I am the first one that's adding the join. A good thing here is to use, for example, named bindings. And then in Ecto, there's a relatively new function. You can say has named binding. And then you know, okay, this is already joined. I can use it in my filter. Or maybe it's not there yet, then I need to add the join. So it's possible to have some level of, let's say, dynamic and conditionality of the queries, but it's generally getting complex very quickly the more the queries grow. Of course, this is, in theory, the most efficient way to make database queries, but only for the database, not for your brain. Another thing that Ecto provides is preloading data. So one thing is the repo.preload, or you can also add preload to queries. Preloading means when you have defined associations in your Ecto schema, you can tell Ecto to load them automatically and nest them within your structs, within the maybe data you've already loaded or that gets loaded as part of the query. Then Ecto will go and detect all the IDs. It needs to fetch the associated records from the database and will nest it inside your structs. And then when you do this, any code that needs to access those associations has them already available. So this is most easy for your, let's say, for your brain and for your mental model of what you're trying to achieve. But of course, as the code base grows and the complexity increases, you tend to add more associations to the preload, just in case you need them further down the line in some of your conditions. And this is a problem because A, it's not that efficient in terms of resources, and B, you still need to remember where's the data preloaded and where isn't it. So when you look at a single function that runs some conditions, for example, in Elixir, you need to keep in mind what do I have preloaded here, and that depends on where it gets called from. So usually you have one entry point where you call it from, which does all the preloads, and then runs everything further down the line, which also means you can only use that one entry point, at least conveniently. So you cannot, you open a console, poke around with the data to just use fractions of your code. You always need to keep in mind what needs to be preloaded. You can also have additional preloaded data. I mean, not preload in the sense of associations, but just preloaded. For example, I worked in a team where we have calendar-based metrics and conditions, and then you need to know for any given day, when you need to come up with the metric, you need to know the 20 days before in order to come up with something. So when we run the calculations for a given day or for a given week, we load the previous week, 2 weeks, let's say, and pass that in as an argument. And that argument gets passed on to all the functions down the line, which need to work on the data. A third option is to use virtual attributes. It's basically a combination of the two. You define some virtual attribute on your schema. That means you yourself, that it doesn't come from the database. You're responsible for populating it. And then you could populate it with some data that you preloaded also from the database, that loaded in a query. And what we call that was decorators. So basically you query something and put it in the struct. And that basically is the same idea, all of these. And so the problems with the existing approaches are you need to keep in mind what's loaded where. You have the risk of overfetching, which mainly means resource usage, but also latency for the users, which you want to avoid. And you need to pass around additional data, so you have additional arguments, you need to keep track of them. You have strictly defined entry point, and so it's hard to change. any given function that may be a bit deeper down your call stack. And so it's hard to scale because as complexity increases, all these things you have to keep in mind increases. And I guess it's possible because we're used to that and we always know exactly where our data comes from. But today I want to present you a new approach. It's a DX approach. DX, by the way, stands for data-oriented Elixir, and it borrows some of the ideas from NX, at least in terms of how you define your functions. So I want to do a live demo here in Livebook. This Livebook is also in the GitHub repo now, so you can also play around with it yourself. And so what does it mean when you use DX? You define functions using defd. And within your defd functions, you can treat all the data as if it's already preloaded. You don't have to think about, is it preloaded or not? And DX will handle loading all the data as needed, when it's needed, in an efficient way, with batching and concurrently. So here, for example, we have this schema is a to-do list with lists and tasks, and so here we have a simple enum map on tasks, and each task we map the created by, which is a user, last name. And so in order to call this from somewhere, you can basically call the function and you pass in some tasks. So let's say these tasks, for now we load them using Ecto. And when this gets run, I enabled some formatted SQL outputting here. So first we have the SQL query for the tasks. That's of course the repo.all. Then we get a warning here, which I'll come back to in a second. And then you will see it selects users where the ID is in a bunch of other IDs. These come from the tasks. Task.createdBy has an ID stored, foreign key, just as you would do a preload. So in a very, let's say, basic way, it will act as a preload, but automatically and only when needed. And this warning here says, please use the load function here. And this is just basically a syntactic sugar, but it's important also for the understanding because this function here basically never loads any data by itself. It always returns either OK and the result, internally I mean, either OK in the result or there are some data requirements that are not fulfilled and returns them. And here, this part, when you call a defd function, basically that's your entry point, it will run the function, and if it's okay, then return the result. If it's not okay, and there are some data requirements, it will load the data requirements. That happens with the data loader library in the background, and then run the function again. And maybe this time, internally there's also an additional argument added with all the loaded data, and this is accessed internally. So basically there's a recompilation happening from defd to Elixir code. And so when you call it here, then it loads the data, calls the function again, and then the second time, in this case, it will return the data because there's created by, okay, that's an association that needs to be loaded. The first time it's not loaded, the second time it is. And last name, it will then realize, okay, this is not an association, this is just a field, so that's already there. And you can actually, now when I run it again, actually this is the macro, so we need to require it first. Then the warning goes away. And this helps to identify the entry points in your code. That's why the warning is there. I'll talk a bit more about this. You can actually, to see these data requirements, you can run get instead. That's basically not loading anything. It just runs it once and returns the result. So probably you won't need it in your application, but it's maybe sometimes nice. And in this case, then we see, okay, the tasks query is the one we do manually here, repo.all. Then that's it. And what we get returned here is a very long list of not loaded tuple, and then it uses map set. It uses a deeply nested map, basically, to keep track of the data requirements as something gets called. And in this case, we have one tuple association for this task, and the association is called created by. And these are batched together, because this is one data requirement for each task. And then data loader, DX and data loader batch it together. Okay, so within defd functions, you can call other defd functions, and it will have the same result. So you can really structure your code as you structure your Elixir code in modules and functions, and you can reuse everything. So let's say we define user last name as a separate function. What's that? User last name. Thank you. Okay. Now we still have the get here. Let's make it a load again with a bang. That means if there's an error, it will be raised. And yeah, it just amounts to the same thing. So, and this could be in another module as well. And yeah, I'll show some more examples. So that these are the basics. Let's get a bit more to a bit more interesting use case. It's authorization. So, for example, you have a user, and this is a to-do list app. So you want to know what lists the user is allowed to see. And so we have a function, a defd function called visible lists for a given user. And if the user's role's name is admin, then we return all the lists. So what you can do, you can run, for example, enum functions on records. So let's say the list, for example, has the title main list. Or you can also, yeah, this is basically when you want to load additional data. Let's say admins can only view main lists, and if it's not an admin, then a user can see their own lists. And now we run this. we still have the required from the last cell, so we need to get some users. Oh, let's get an admin. Maybe how do we do this? I used another defd functions to do this. Get an admin. And so, as I mentioned, you can use enum functions also to load additional data, not only associations, based on the schema. A bit like you would do when you start an Ecto query. You can also start with an atom, with a module specification. So let's say we want to find a user where their role name is admin. And here we say get an admin. Oops. So this find, because there's no data loaded yet, it just basically runs a find on a full schema that gets translated to SQL. So in this case, it needs to make a join for the role and then match on the role's name. So that's what happens here. From user, inner join roles, that's the association you've defined in your Ecto schema, where the role's name is admin, and because we have an enum.find, it only limits it to 1. It only gets the first one. And here we get a user returned. And for this user, for this admin, now we can say get their visible lists. Oh, it's only called visible lists. Then it will just run. So here, it will first make basically look up the role again, because this is now a separate defd function here. A different run. So it goes in here and does the preload thing. So basically, it always tries to translate or translate your code to SQL. And if that's not possible, or maybe it also already has the data loaded, then it will act like Ecto's preloading. So it will load data as needed. And here, for example, because we have the if, it does that first, and then either runs this query or this query, depending on what this returns. So you never load data that you don't actually need. And here we see, okay, that's the roles query, and then since it's an admin, and I've made an enum.filter here with matching it to the title main list, this is what it translate the enum filter to. Very basic example for this. And as before, you could, for example, define a predicate like a helper function user. Probably this would go into another module, but for now I'll put it here. And this is then we can reuse it and run it again, and it does the same thing. So you can really write Elixir and run it in the database. What's also nice is that, as I said, queries are batched automatically. So for example, now we wrote code with the user in mind, but we might want to get the visible lists for multiple users, or let's say all of them. So I'll make another defd function to say get users, visible lists, and maybe with an enum.map, and then we get, let's say we make a tuple with the user ID and then their visible lists. And we call this here instead. Let's get all the users. That's more fun. This we don't need for now. So what happens now is you don't get an n+1 queries situation, but it will check what data is needed. And so first we query all the users. Then it needs to query all the roles that appear in all those users. Apparently that's 4 different roles, just like you would do in an Ecto preload, in order to run this if function here for each of them role. Then it will load lists where the created by matches some IDs. That is for the people who are not admins. We said user.lists. So for those people, we need to go by their created by association. And it will also load all the lists whose title is main list. It will run this query once because it's the same result for all the admins. And so as you get more complex with your code, it will still keep the amount of queries that are run efficient. And let's do a bit more complex query now. So we have a filter here. We want to get dormant users. This is maybe some kind of business logic where we say these are good candidates for either writing to them or maybe deleting their accounts. So here we also already have a defd function again. Dormant users, we pass in a threshold, how many days old should they be in order to be dormant. And the definition is we filter, we take all the users, we filter by, okay, they don't have any lists, so the count of their lists is 0, and they were verified before the threshold. And in DX, these enum functions, as long as they can be translated to SQL, it's lazily evaluated. So in this case, the two filter functions are merged together, and only when the data is needed, or at the very end, at least eventually the data is needed, it will run the query. So here, when we run this, we get one query that says from users where the count of the lists created by them equals 0, and the verified add is smaller than this timestamp that we passed in here, or that we actually generated here with datetime.shift. And this is another example. And this, yeah, again, this could be used directly or could be used in any other defd function. You can then do enum.map or whatever. So right now, what gets translated to SQL could be enum filter, count, any, And yeah, there will be more functions, but yeah, I'm still working on it. But this is basically what it can do and how it helps you to keep your code clean and the code structure clean while making queries efficient at the same time. And as you can see, I now poke around with the data in the live book. Unfortunately, right now, you still have to first define a defd function. Later on, I would like to make this maybe more powerful, so we can put the, for example, the enum.find in here directly. That's not possible yet, but these things are basically already built in. And some caveats. First of all, as I mentioned, the defd functions can be run more often. So whenever data is not loaded yet, and that also implies queries, for example, that have not run yet, it will get loaded, and then the function will be run again. So it's not designed for side effects. Side effects meaning you insert something in the database, or you even when you print something. I mean, you can do that, but it can be run more often. And so, for example, debugging might be a bit more difficult for now. There might be ways to make it easier that I'm investigating, but for now, this is a caveat. Just bear that in mind. And I mean, it's not supposed to cover all your application. It's just basically for the logic that you would otherwise maybe write queries for. And defd functions should only call other defd functions. They can actually call into non-defd functions, but then, of course, it cannot be translated to SQL, and inside of that, there can be no preloading because it cannot kind of look into that if it's not defined by defd. But that works as well. And as I mentioned, not all enum functions are translated to SQL. I started with filtering in general, and I think that's where it has the greatest benefit. Maybe later on sorting could be translated to SQL as well, and maybe even later on enum map, basically mapping. But for now it's filters. And it's good to keep in mind this logical split between the defd function where you define your logic and then the entry point where you call it, as I mentioned. But this is actually a nice thing, I think, because it helps you structure your application as well. So here's a suggestion that comes from the hexagonal architecture idea or concept. You divide your app into periphery and the core. You can actually call this module namespace something with core, and that has your defd functions. They can reference, they can call each other. So you have a nice core of your business logic, and then the periphery would call inside the core. So for example, it's responsible for process coordination, receiving requests, control flow in general. Like, I don't know if you have a web app for the redirects and other things. Yeah, controllers in a web app, workers, how they are spawned, and live views. And then the core would have, for example, the business logic, predicates like I showed with the admin, and filters, authorization, these kinds of things. Yeah, in the future, I would like to make a robust extension API, so you can also make libraries easily compatible with DX. I would like to apply it to Phoenix templates or components, because basically once they are compiled, they are just functions returning binary lists, and this is actually a good fit. Then you would basically define your template, and the X would fetch everything that it needs from the database, put it in your template, send it out to the client. I think that would be very efficient. And also for data sources, there could be more. Right now, only Ecto is supported. I tested, we're using Postgres, but the livebook is with SQLite. That also works. And maybe combine different data sources in the future. So to make it short, maybe you start with n+1 queries when you're still learning how this whole thing works. You might be used to Ecto queries and so on, but in the end you might switch to DX. That's what I hope I could convince you of. So, thank you very much.
Okay, I see we have questions. I think we have time for one or two.
Could you go back to the live book with the admin example?
Yes.
Yeah, right. So, like, two quick questions. Can you pipe get an admin into get users visible lists at the bottom? Or would you have to make a new function that's defty?
Here? Or here?
Like at the bottom, yeah. Would you be able to type two defty functions into each other?
You couldn't. What you can do is you can pipe it like this.
Without a load, yeah. That's.
But yeah, I mean, I just showed. I made two different defd functions here, but it's always good to only have one entry point, and then everything that's defd is within that. So.
Okay.
You should not, ideally not pipe this again into another defd function when it's already loaded once.
Okay.
But yeah, you can pipe that, yeah.
And also, just quick question with the admin question mark there. Does it load the lists for the admins even if they're not used in the query?
No. You mean here?
Yeah, because you get the main lists, but you get lists for everything else. But would it get the lists from the result in the Ecto query? It just wouldn't use them for the admins.
So if this always evaluates to true, then this will never cause any queries.
Sure.
Is that what you mean, or
No, but like if sometimes you get admins and sometimes you get non-admins, is it going to get the lists for the admins and then just not use them? It's okay. We can talk about it later, probably.
Yeah, that would be good.